Welcome to a new episode of Technoculture. I am Federica Bressan, and today my guest is Dmitry Kaminskiy, founder and managing partner at the Deep Knowledge Group, a consortium of organizations focused on deep tech, AI, and longevity. Welcome, Dmitry.
Hello, it's my pleasure to be here today.
Thank you for being here. So, longevity is much more than just extending the human life. How we achieve this goal and all the consequences that come with that have so many ramifications that actually you consider in your work. So we have so much ground to cover today. Let me ask you right away, how do you understand longevity and how is that different from aging?
Okay, so aging, as you can understand quite easily, has some negative connotation. Aging it is a degradation of the body and some negative biological process associated with aging. For longevity, these are technologies and methods and treatments which are capable to provide extension of healthy, active, productive period of life. In other words, to delay aging as much as possible.
All right. So, in this podcast on episode 11, I covered transhumanism. Transhumanism is the radical use of science and technology to achieve the extension of human life and what the human body can do. So how is this different than what you do, or what is the overlap there?
Okay, transhumanists, in other words, could be also named radical techno-optimists. They have hopes, they have assumption that in 20, 25 years from now, they will be achieved singularity. There will be extremely advanced technologies capable to extend life very significantly, but at the same time, even to make so-called mind upload. So to transform human into cloud, into digital, into virtual personality. So that will mean immortality, actually. So they believe that either body will be capable to, apply some technology which will be almost infinitely to extend biological life or to make mind upload. But this is about far future, and there is not enough yet clarity whether and when it will happen, and whether this mind upload will be possible at all. At the same time, currently, with currently existing technologies, there are many people naming themselves biohackers who are applying already now existing technologies. They are doing also some radical stuff in the sense that they're experimenting on their own bodies, trying to achieve something with currently existing technology. So in our case, we are not so radical as biohackers. We are kind of also experimenting on our own bodies, including me, doing it, in a little bit more risk-averse and science-driven way, without too much, exceeding risk level, and those experiments were kind of done in a reasonable, pragmatic way. At the same time, we are not so much abstract as transhumanists who are thinking about too much far future. So we are thinking about comparatively close future, and we are applying technological forecasting to predict and, to actually, first of all, to predict for us ourselves, and to invest in those technologies and to bring them, to market faster. We are talking about such periods of time like 3 years, 5 years, 10 years. And we are naming this techno-pragmatism.
All right. So how does longevity look like? Like in 3, in 5 years, how long will we be able to live?
7 years ago, 8 years ago, when I entered this field of aging research and, longevity technology, longevity industry, to talk about that people can live up to 120 years or average lifespan will become 100 years, it was considered as fringe, as a kind of, absolutely too much optimistic. In nowadays, it is absolutely normal that quite established businessmen, quite established, even maybe politicians, they are talking about that there will be technologies already now capable to deliver probably lifespan for particular individuals up to 120 years. Some of them even talking about 150 years or even 200 years. And this is not considered as let's say 120 years is considered now normal, and expectation that in some developed countries with very well developed healthcare systems, the life expectancy will grow up to 100 years. Just for understanding that in Japan, Hong Kong, Singapore, they are almost already there. So they have, 87, 90 years, 92 years life expectancy, with health life expectancy around 82, 86 years. That means that those people on average, they're not only living longer, but they're living healthier longer. So the healthy period of life is quite significantly longer. And this is quite significant achievement. My point is that maybe in 10 years from now, to talk about that life expectancy will be 120 years, it will be already quite pessimistic.
All right. And you mentioned that you are conducting some experiment on yourself, actually. Can you tell us a little bit about that?
Let's say I can tell only a little bit about that, but in our group, we have approximately 10 analytical subsidiaries and 10 analytically focused companies, including, for example, neurotech analytics. This is about, neural enhancement and helpful brains. We have space tech analytics, and this is about space exploration, but also about space medicine, which is quite important for aging research, and several others focused on AI, DeepTech, blockchain, so on and so forth. But the first one in our group of analytical subsidiaries, it was Aging Analysis Agency. It was established back in 2013. And this company, to my knowledge, the only one currently existing analytical company specifically focused on science of aging, technology, business of longevity, even longevity politics. And the point is that within that company, we have specific department named Practical Longevity, several tens of analysts specifically working on analyzing all currently existing technologies, so technologies which are estimated to be soon close to the market, and they're analyzing also whether how they're safe, how they're not safe, what could be side effects, and those technologies which are recommended, to use and to apply, maybe in some, let's say, subtherapeutic dosages, so with some adjusted, regimes. So we are in opinion that it's reasonable to use them. In particular, if we're talking about such technologies, one of the quite efficient and really working, it is so-called intermediate hyperexia training. Many people know about this technology through awareness about hyperbaric chambers. But hyperbaric chambers, it's one of the specific regime how that intermediate interval hyperexia training are actually used. So in hyperbaric chamber, there's excess of oxygen. There are another technologies, they're providing similar effect, in some cases more efficient. They're using, let's say, deficit of oxygen. So in my case, I'm using a specific training machine. Initially, it was developed within Soviet space medicine program, and it was used for Soviet cosmonauts training, preparing them, and also for some kind of divers and let's say people who are expected to be in some extreme environments. This technology, just for understanding, it is providing capability to train your mitochondria to withdraw a weak mitochondria from cells and to boost the regeneration of mitochondria and cells. This is let's say energy accumulators of cells. At the same time, this mitochondrial dysfunction is one of the most root causes of aging, associated with let's say aging associated dysfunction of the body.
You mentioned space medicine. I wonder, why does it have such a big role? Just because astronauts age faster when they're out in orbit? It's so fascinating that we may exploit this technology on Earth, although we will become a spacefaring species, but that now already space medicine helps us delay aging.
So in space, astronauts, they're exposed to extreme negative impact of number of factors, starting with zero gravity, increased radiation, and many other issues which are already known, and many of them unknown. And let's say some of them are known when humans comparatively close to Earth. But if we will talk about going to Mars through deep space, so there will be a lot of unknowns and unpredictable, negative consequences. But even with what we already know so far, zero gravity provides extremely negative effect on mitochondria. And as I mentioned, mitochondria is also associated with aging, or mitochondrial dysfunction is associated with aging. In other words, what astronauts are experiencing in space, it's from biological point of view, it's very similar to what could be named accelerated aging. Astronauts, however, currently it's people who actually sent to space. By definition, they are very healthy. They have very strong immune system. When they're getting back to Earth, the immune system is capable to restore this, damages which happened, that negative consequences of being in space. It is absolutely not clear what will happen with, let's say, not so young people if all people will be sent to space. We have some, assumption that once they will get back to Earth, those damages, they will be not fully restored. And this, you see, space medicine is also differentiated from, let's say, Earth medicine, in the sense that in space, doctors, they're actually making some advanced scientific R&D, let's say, focused to protect health of astronauts. They're also human-centered, whereas on Earth, it's through the decades, it happens so that scientists who are working on anything related to aging, they don't have any, deadlines or, strict circumstances. When they need to solve problems fast, like really, in days or hours. So they have close to unlimited, timelines, and they can make unlimited, experiments on model organisms, which are not, so let's say the mindset is not human-centered. On the other hand, everything what will be working in space and those extreme hazardous environments and will protect health of astronauts if those technologies would be applied on Earth in normal environments. So apparently they will work like 100% guaranteed they will work. Maybe better and maybe more efficient. Or let's say they will also work not only for super healthy people, but also for people with some, health conditions, maybe old people.
So when an astronaut goes to space now, we can indeed observe what would happen to one of us in similar health conditions if the process of aging were accelerated. On Earth, normally, research aimed at extending human life is conducted with model organisms. What is the problem with that, in your view?
Okay, so in biotech industry, in biopharma industry, the currently existing framework for R&D, for research and development, for experiments, for validation, approval of different drugs and treatments, for assessment of their safety and efficiency. During decades, it started 70, 50 years ago, there was established the system when experiments first, they conducted on mice, and they're showing very systematically positive results. Then in very limited level, they also tried on humans, and if they're showing absence any kind of such negative effects, like any toxicity or any kind of issues, then they're tried on more broader groups of people. So this is human clinical trials, several stages of them. In case of biotech industry, pharma corporations, they are focused on finding the drugs and treatments focused on one specific disease. So one specific treatment is treating one specific disease. Or in it is named one specific target. So the genetic and biological, let's say, pattern of diseases evolving in animals, including mice, they're similar to humans. That's why their drugs or treatments which worked on mice, in many cases, then after that could be translated to humans, and there are some statistics how many of them actually succeed in humans. So the point is that only 8% of those treatments which provided positive result in mice, they were translated to humans. That was with disease treatment, with sick treatment. When we're talking about aging and longevity, this is we have assumption that aging is absolutely different. Like it's much more complex, like maybe 1,000 times more complex than any one single disease or even combination of diseases. In other words, if it worked in more traditional biotech, biomedicine industry, there's no significant evidence that this translation in case of aging research and actual practical human longevity will work similar as it was working in biotech industry. We have estimation that if the failure rate in biopharma industry is 8%, actually success ratio is 8%, failure rate is 92 correspondingly, that in case of longevity, the success translational ratio will be only 1%. That means that mice is absolutely not, if it was sufficient for biopharma industry, it will be absolutely not sufficient for longevity industry. And we need, and we're considering that in my upcoming book, Longevity Biomarkers, I'm providing some, results and some evidence that mice as an experimental model is outdated model. It's not sufficient. It's not, up to date for 21st year of 21st century for aging research and for practical human longevity. We need new, much more robust, much more sophisticated data science, AI-driven platforms for experiments. And the only one real biological sufficient platform, it is human body. However, the experiments, the assessments, that should be driven by very strong, very advanced data science with very strong AI algorithms to assess, and that there will be any negative side effects before even starting any trials.
You just mentioned you have a book coming out, Biomarkers of Human Longevity. What are these biomarkers to begin with?
In any domain of biopharma, biotech, especially biomedicine, biomarkers are absolutely crucial. It's like markers or metrics with which you can assess in advance whether any results could be, tangibly positive or negative. You can in real time assess whether any treatments is providing any positive or negative results. For example, 10 years ago, cancer, was considered similar to death sentence. So, it was like it was considered as almost untreatable disease. In nowadays, cancer, in many cases, it's complex, but nevertheless treatable disease or, manageable disease. And tremendous progress in cancer and oncology field happened because cancer biomarkers, it's one of the most well-developed field of biomarkers research in general. And because, doctors can understand very well the picture of cancer and test and understand whether any drugs or any treatments actually worked or not worked. So this is one of the crucial elements which accelerated actual cancer research and, and boosted some, including investments, including, a lot of initiatives which provided very strong positive results in oncology and the kind of, sub-industry of biomedicine. So that's why biomarkers, it's crucial for any biomedical industry. In longevity, the field of biomarkers is yet underdeveloped. There's quite a lot of activities during last 2 years, but there was not enough, let's say, 3 or 5 years. That's why we can expect that the real strong progress, strong development in this field will happen in the next 2-3 years, and that will be the crucial turning point in the entire growth of longevity instinct, including science of longevity, actual progress in practical application of human longevity, practical applications of preventive medicine, personalized medicine. And this will lead to really strong progress in 5-7 years, also in more advanced, really rejuvenation technologies such as stem cells, reprogramming, such as anti-aging gene therapies. And with that, we can expect that approximately 10 years from now, those technologies will also reach market, and people will be able at least to freeze their biological age, and in 15 years from now also already start to reverse it, to rejuvenate their biological age.
So with the help of technology, you think that it's actually possible not just to delay the process of aging, but to revert it in part or for certain parts of the body? We're talking about rejuvenation.
First of all, those technologies, many of them already now existing. However, if they would be applied on humans now, they will bring side effects, negative side effects. Some of them, let's say, they will rejuvenate, but they will also can cause cancer, unfortunately. And on the other hand, in 10 years from now, in 15 years from now, science and technology will understand how, to switch off negative side effects, how to kind of provide through those treatments only positive effects of rejuvenation. So in other words, it is not about whether this technology will work or not. It's only about when they will work, because some of them will work in 5 years from now, in a sense that in 5 years from now, we will see that they could be applied in a safe mode without negative side effects. Some of them will be market ready in 10 years. I think that many, there will be abundance of them in 15 years.
In order to achieve these goals of longevity and, of course, a healthy long life, technology seems to have a very crucial role. Like, we're not going to get there without the help of technology. And in particular, artificial intelligence is key to achieving these goals. Can you talk a little bit about how central this role of AI is?
Yes. So if in 10 years from now, there will be estimated 10 years from now, there will be technologies for rejuvenation, so-called, a little bit more radical technologies. However, already now, there's quite a lot of technologies which actually can help to delay aging. In 5 years from now, there will be a lot of them. And to actually apply them in a reasonable, in a sophisticated way, we need to apply very strong data science to healthcare, to, let's say, healthy lifestyle management. This is much more complex than most people can think. And the only one way how to make it in a really tangible, really, really workable way that it will be really deliver practical results, it's only if that advanced data science will be managed by artificial intelligence. In other words, to achieve any reasonable practical results in the foreseeable future, we first of all shall apply artificial intelligence in a personalized way for management of your health.
What is a digital twin?
Number of companies, approximately 6 of them, are now developed their panels of biomarkers to such extent that it could be considered as prototype of digital avatar. Digital avatar is a combination of all your biomarkers or any data which is emulated into virtual environment as if it is your digital avatar. That means that all your life and healthcare data, all diagnostics on all MRI scans, all parameters of biomarkers of aging longevity, many other biomedical parameters, if they would be aggregated in some kind of cloud computing system, so that could be considered as a digital avatar, and also visualized actually digital avatar with some dashboard for quite advanced, sophisticated analytics. Now, if this digital avatar will be really developed, let's say for next level, next generation, you can consider that digital avatar as a digital twin. That means that a lot of Because when we're talking again about longevity, we're talking about data science. That data science should be somehow structured, that actually science to be applied in a reasonable, sophisticated way, the data should be structured. And this digital avatar and digital twin is just the way how in the modern world, the data about your all processes, like biomedical, biological processes associated with your body, how they could be structured.
All right, so it's like a model of me, and we can make simulations with that model.
Even more, it is virtual model of you, and there is such a type of experimentation and research named in silico, when experiments would be done with the help of artificial intelligence virtually, and there will be assessment and prediction what is healthy for you and what is unhealthy. In other words, before doing anything, that something should be trialed on this digital avatar.
So something that is really interesting about your work is that with such, I don't even want to call it optimism, because for you it's just a matter of time, it's not even of belief that we will live longer and healthier. This will reshape society. For example, we're going to talk about this a little bit, but something that I wanted to mention is this thing in our society that, in fact, we don't talk about enough, which is ageism, which is a form of discrimination that affects senior citizens. How does your work tackle this?
In Europe, in some developed countries, including, for example, UK, there are quite a lot of initiatives to tackle down the problem of financial inclusion, in the sense that there are at least 2 billion of people somewhere in Africa and Latin America, in some, let's say, problematic regions, which are not financially included. First of all, because they're not digitally included, they are not having access to internet, they do not have smartphones, and with that, for them, it's quite problematic in order to have access to any even basic features of modern civilization, including integration with any fintech or banking or financial services. And this is a very significant problem. But just in the UK, out of 70 millions of people, 10 millions are in retirement. And most of those people, they are discriminated in the sense that, they're not treated as equal members of society. This is normal that they do not have equal access to, let's say, fintech services. And when we are talking about financial inclusions, the most excluded financially category of people, it's actually old people. Because, for example, you hardly will find anyone no-profit foundation which is working on financial inclusion of all people in developed societies. But there are quite a lot of charities which are working on financial inclusions of young people somewhere in Africa, let's say so. One of the projects which we are supporting is longevity banking card. This is fintech project, but it will provide services specifically designed for old people and even very old people, like older than 70, 80 years. Because for them, even devices, how they communicate with fintech services, it should be not smartphones, it should be tablets, there should be big buttons, and there should be voice commands, and the hardware, software, and even a specific approach how to communicate with them, it should be very different, not as it is normal, with younger people for fintech service. So my point is that this is one example. There's quite a lot of other examples. This is very, big topic for discussion. But my point is that I think that countries where life expectancy will be growing, countries where healthy life expectancy, such as Singapore, Japan, will be growing and is growing. So they will pay more and more attention also on even political level, not only on policy level, to provide equal rights and actual access to all services equally as for young people, the same for old and very old people.
So to conclude, because unfortunately our time is running out today, we have covered a lot of ground, but as just you were saying, there's the impact of successfully extending the human life and reshaping society is manifold on many aspects of life. And you are a prolific author, so you actually deal with these aspects of the issue in your work. Would you like to briefly give an overview and mention the different sectors of life and finance and technology that you wrote about, for example, and that longevity will make a difference for?
Yeah. So first of all, in all my books, there's the core idea that we are facing now two big mega trends on global scale. One of them, aging population. There are more than 1 billion people in retirement globally. You can consider them as citizens of seventh continent. On the other hand, we are witnessing extreme growth of very advanced technologies, AI-driven, data science-driven, technologies for preventive medicine, for personalized medicine. A lot of breakthroughs in applications of digital medicine, AI in healthcare. So these two global megatrends, aging population and health longevity, being accelerated by impact of technologies and AI. When we are considering longevity industry, indeed it is the biggest and most complex industry in human history. My first book, Longevity Industry 1.0, defining the biggest and most complex industry in human history. That was about what this industry right now and what sectors, components are actually comprising them. We identified 20 sectors which are actually comprising longevity industry. It is medicine, it is young healthcare, it is also neurotech, health of brains. It is also age tech. This serves specifically for all people, and there's a lot of other non-specific domains. My next book will be longevity biomarkers, because this is the very crucial metrics. Without metrics, you can't talk in any tangible, reasonable way regarding any industry. Longevity in particular, because this is the most, not only most complex, but also most deep to extend human life, especially healthy period of life. It will require very deep technology, very deep tech, advanced technologies. The last book in this series will be Longevity Industry 2.0, Deep Tech Engineering, the Positive Trajectory and Sustainable Growth of Longevity Industry. So it will be about what technologies will be developed in 5 to 10 years from now. It is about technological forecasting and also identifying the most crucial roadblock and slow down factors which will have to be resolved definitely and ensured to be resolved in 5 years from now. That will be guaranteed that in 10 years from now, positive results of technological progress will be delivered to people in terms of practical longevity, and actually on a global scale. So it's also about distribution of this knowledge, expertise, and technologies across all humanity.
I find the span of your work interesting because sometimes technology runs ahead of all the rest, and actually we have to think ahead about at policy level how to keep this development sustainable. And I like to agree with you that it's a matter of when and not if. So wouldn't it be nice if we could have another interview in 20 years and look just the same? Because either we haven't aged or we could revert in part that process. But today I would like to encourage the audience to visit your website to learn more at www.kaminsky.info to check out your books. And I would like to thank you very much for being on the show today.
Thank you very much. It was my great pleasure also.